Hello, my friends. Welcome back. We are building the welcome message project from the YByte Python curriculum available at www.ybyte.in. We saw previously how we could make our function short form more robust by giving a try and except statement, which is basically making the program safe in the sense that it wouldn't crash. For example, let's say I call this function with 4 arguments. We need YByte Bengaluru, but 34. Now 34 is a problem here because that's an integer. And this statement over here causes a problem. Now, because of my try and except, the function won't crash, but it'll just tell me, look, something went wrong. So function has kind of saved itself. But think about it. This something wrong is so generic that it's not really helpful. In fact, we would want to give a message that is useful to the user so that, he or she can then possibly fix the error. Which means that what we are looking at is that somehow we should get back more information about what is it that went wrong. Now, before I get into, let's say, trying to understand how we do it, let's just try to think about why we even think this is possible. Well, the reason is we have been doing a lot of programming and we know that, look, whenever we make a mistake, whenever an error happens for various reasons, we get a fairly detailed message coming out from our, let's say, interpreter telling us what type of error happened. And, that is quite helpful for us to debug. So in the same way, it's very reasonable to expect that, look, if something goes wrong in my function, it should be able to give me back, for example, a more detailed message. Now, what can that message be? Well, let's look at some errors that we sometimes make. For example, let's say I have an integer 12. I try to, let's say, subscript into it, index into it. I get an error that, look, type error. Basically, int object is not subscriptable. So basically, whatever I'm trying to do is not available for this data type. In fact, that is exactly the problem that's going on when I say something went wrong. Similarly, let's say I have, let's say I try to print a variable b without having defined it. Well, that's a problem because it tells me that's a name error. I do not know what this name b means. Name b is not defined. In fact, we can get another very common type of error. For example, if I try to convert int into, let's say, convert an integer, a string like, say, ABC. Now, this is what is called a value error, which means that the function that I tried to use, I did not provide the right value for it. Actually, at this point, it's quite interesting. Why is this not a type error? I mean, type error basically happens when I have a wrong data type. So why do I think int ABC as a string is not a type error? Well, the reason is I can actually convert, strings to integers, provided they are convertible. So here the problem is not the fact that I've given a string, but the problem is the fact that I've given a string whose value is not conducive to the function that I'm using. And that's why that was a value error. Now, in fact, we have seen a lot of these. So these information exist. Now, here's a list of some common Python exceptions that you may have encountered or you will probably encounter as you program more. Now, this list is obviously not exhaustive by a far way, actually. But this is just to give you a flavor of what type of errors we might encounter. Again, just like everything else, my prophecy is that, look, rather than trying to memorize this, let's try to see them in action. For example, we just saw name error. It happens when a variable has not been defined. A type error when there's a wrong data type involved, a value error when there's a wrong value given. Let's look at a few more so that we understand them better. Let's say I try to import a module which does not exist. For example, import RNDM, assuming I've not created a module myself of this sort. That turns out to be module not found error. Let's say I try to, let's say I have a list called, let's say 1, 2, 3, and I try to index into this list by giving an index which is too large. Well, that is an index error. It tells me list index out of range. Say I have a dictionary, let's say I have a dictionary which is 0. Say 0 is a key, 1 is a value, say, let's say 10 is a key, 20 is a value. Let's just say 2 items in this dictionary. If I try to look at, let's say A12, that is going to be a key error because this particular key has not been found. Similarly, let's say I have a number which is, let's say 12. I try to divide this by 0. That gives rise to what is called a zero division error, as the name suggests. Division by 0 is not allowed, and hence this happens. Now, this is very likely, for example, in our calculator project, right? If the user is not careful, does a divide by 0, in fact, we are almost certainly going to raise a zero division error. Point I'm trying to make is that the interpreter, in fact, has information about what type of error has happened. And hence we can use this. Now, like I said, this list is absolutely not exhaustive. However, I want to make an important point here that indentation error and say syntax error, these are very, very, very unlikely to happen at runtime. It's assumed that, while developing the program, the programmer has taken care of these and fixed all of this. Hence, we are looking mostly at runtime errors. Now, in case you're interested to go deeper into this, there are some links that I put in here. But mind you, this topic can get quite overwhelming quite fast. So, again, I always tell everybody the best way to do these things is by doing it, but experiencing them. So let's get on with our code and see how we can implement some of this in context of the program that we are building. I come back to my code. Notice I know that, look, in this case, I'm indexing into a string, say word 0. I know that if anything except a string were to come into me, that is likely to cause a problem, and the problem will be a type error. So I can say, look, instead of just saying, look, except something went wrong, I can be a little bit more specific here and go and say, well, except, for example, now pay attention to the indentation here. This except is in fact a part of the same hierarchy as try and the other except, but this time around I go and say, well, except, for example, type error, because that's what I was expecting. I can go and say print, let's say, wrong data type given, let's say. Now notice this message is clearly a lot more descriptive. The moment I tell my player, look, wrong data type given, it immediately alerts the person that, look, maybe I'm giving some wrong inputs, right? Rather than saying something went wrong, because something went wrong is too generic, right? Doesn't really help. Let's see this working. And when I now call, for example, short form with input of 34, it tells me wrong data type given. Now, the function did not crash. That's good. Additionally, the function told me, look, something wrong was given, and that immediately alerts me, oh, okay, maybe this is the problem, right? And I could fix it. In fact, I can go deeper than this and I can give a little bit more information. For example, let's say I say, well, for type error as E. Now, basically, I'm saying that, look, the type error object has been, I'm naming it as E, and I'm just saying, please print this error for me as well, right? So when I do this, it's actually quite interesting. Now notice when I run this piece of code now with the type error as E, it in fact tells me wrong data type given, int object is not subscriptable. Now this is quite interesting because notice immediately this will alert me to the fact that, look, I have given an integer and that is probably causing a problem. Contrast this with, let's say, saying something went wrong, and you clearly see that this is much more useful. So in fact, what we can do is, we can enhance our try and except statement by saying what type of error I'm expecting. I sort of, as a developer, anticipate that, and then I can do a subsequent action, a suitable action according to the error that I've received. Now, before moving further, I just want to illustrate something quite interesting to you. For this purpose, I have brought back my return statement. I've uncommented it. We will actually look at this much more closely later, but for now, I've just uncommented it. And I brought it to a level of this indentation, which is same as the try and except, which means I'll try all this. I'll come out of this and let's say return the value, whatever that is. Yeah. Now, when I, let's say, run this piece of code, if I give, instead of an integer or let's say a string, if I give a list, I expect this to be not a problem at all, because remember, all these arguments will become a tuple inside my function because of star words. And I run through these tuples these items one by one in this for loop. Clearly, word will become a list at that point, and word 0 is accessible. And hence, when I do this piece of code, I get my SF is VWB ABC, and that is perfectly fine. However, what happens if my first item of this list is not a string, but in fact an integer, let's say 1, 2, 3. Now, this causes a problem. This causes a problem, but you notice something very, very interesting that happened. In fact, this was a type error, but the message that I got this time round was different. The reason it is different is because, yes, a type error happened. It was not because I could not subscript into the list. In fact, I could, but what I got out of that was an integer, and I know that I cannot add an integer to a string. So the point I'm making is that because of, let's say, this, little bit of detail when I'm saying type error as E, in fact, it gives me a lot more information about what went wrong. So, I'm able to tell one error from another, and that is quite useful. As we develop more, we'll look more and more into this. But like I said, the best way to learn this is by doing it. Try to think about how these errors happen. Try to anticipate the errors that are going to come in. Put them in the except statement and make sure and so try to test them so that you get a feel for what is going on. I hope you found this video interesting. If you think this way of learning works for you, where we make activities, where we analyze them in detail, we try to apply concepts, look at our website www.ybyte.in, because that is how we learn Python programming. Take care. Thank you so much. Bye-bye.